Okay guys, for this assignment, Toolbox Math, we are taking a story problem. We're going to then say where it starts, how it grows, create a table, create our equations, and graph it, okay? So Limousine company charges an initial rate of $30 and $25 for each hour. So if you never used any hours on it, okay, it would still charge you $30 to rent it. And then after that first hour, we would add 25 to it, and you'd end up with $55 that you would now be paying. So we're adding, so our growth is plus 25, so it's arithmetic, right? And we started at 30. So that would be 70, 80. 105, 130, 155, 180. So if you had it for 6 hours, it would cost you $180. So we can then use our table to easily graph it, right? And this says up to 10, but we can count by higher numbers. Let's count by 20. So we get up to 200. So 0, 30 be right there. 155, 20, 40 be like up there. Then 280 be like right there. Then 105, 130. Okay, and it would look something like that. Alright? Our equations. So for our recursive, we can go a sub n equals a sub n minus 1. And we're adding 25. And a sub 0 equals 30. For our explicit, a sub n equals 30 plus 25 because it's arithmetic. The n is down low. Alright? Okay, so that's what we're doing. So number 2, Angela receives a base salary of 100 plus a commission of 65 for each computer she installs. Okay, so we're starting, she always gets 100, and then depending on how many computers she installs, she's going to add 65 each time. So this would be the computers installed, this would be how much she makes. Could also call that X and Y. So we start out, she always receives 100, even if she doesn't install any computers. After the first computer, 165. After the second computer, grab a calculator to make sure I'm not making mistakes here. So 165 plus 65 would be 230 plus 65, 295 plus 65, 360 plus 65, 425, and plus 65 would give us 490. Okay, so there's our table. So our equation, easy enough, right? Let's do f of n this time. F of n equals f of n minus 1. Okay, plus 65. F of 0 equals 100. So f of n for our explicit is 100 plus 65. It's arithmetic, so times n. Then graphing it, okay, maybe we can count by 50s this time to get up to 500. So at 1 would be 0, 100, then 165, and 230, 295 would be almost there, 360, 425, then 490, something like that. Okay, and there we go on that one. Okay, number 3. A cable company charges a monthly fee of $59 plus $8 for each on-demand movie watched. So in this one, how many movies we watch will determine the cost for that month. So if I watch no movies, I still paid $59 for the monthly fee. I watched one, I'm going to add 8 to that. So we're adding 8, it's arithmetic again, starting at 59. Okay, so that would be 67. Then that would be 75, then 83, then 91, 99, and 107. So if you watch 6 movies, it would cost $107. For our equation, let's do f of x this time. F of x equals f of x minus 1 plus 8. F of 0 equals 59. For our equation, f of x equals, we would go our start plus 8, arithmetic, so times x. Okay, graphing it, maybe let's count by tens this time. So 0, 59 would be right below 60, then 67, 75, 83, 91, 99. It would look like that. Alright, number 4. Garrett borrowed $500 from his aunt. She doesn't charge any interest, and he makes $15 payments each month. So we're starting by owing $500. Okay. And let's just say we're subtracting $15 from that each month. So this would be months, or our x. Our y would then be how much he owes. So we start out by owing $500. Then after that first payment, it'll be $85. I don't want to mess these up, so I'm going to just use this. Then it'd be $470, $455, $440, $425, and $410. Okay, so my equation, a sub n equals a sub n minus 1 plus or minus 15, and a sub 0 equals 500. My explicit, y equals 500 minus 15, it's arithmetic still, times n. Graphing it, let's start with 500, so we counted by 50s. So we start at 500, subtracting 15 each time. Okay. So this would be 450. I had at 3. I was at 455. And then 440. And 425. Yeah, so this is going to look like that, going very slow, isn't it? Okay. So, number 5, why is it important? What's the importance of the starting number, which we also call the y-intercept on the graph, right, because it's on the y-axis every time, and the slope or the growth, okay? How do we see them in each one of these? Well, let's just use this one for our example. So, knowing where we start helps us on all of these pieces, right? That's our y-intercept. That helps guide where we're going to begin. Then that growth, that minus 15, we see it in all those pieces. Okay. We see it in our table, we see it in our equations, we see it in our graph. Okay, and that tells us where we're going. So we know where we start and we know where we're going, and that's the importance of looking at those. Okay. Alright, number 6. So a limousine company again charges an initial rate of $10 and a payment doubles for each hour. So now we've got some geometric going on here. Okay. So, but that initial rate is still 10, okay? But this time we're doubling. So we are multiplying by 2 each time. So, if we start at 0 and 10, then that first would be 20, then 40, then 80, then 160, 320, and 640. So this must be a super nice limousine, right? So, then we can go f of n equals f of n minus 1, and we are times them by 2. F of 0 would equal 10, and in our explicit, f of n would equal 10 times 2, and because it's geometric, the power goes up as an exponent. Okay, now if I'm trying to graph this, it may be hard to graph everything. So if I count it by tens, we go 10, then 20, then 40, then 80, and then it would go clear up there. So it would look something like that. Okay? Alright, so then looking at number 7, Angela receives a base salary of $1 and a commission that quadruples each week she spends working on installing solar panels. So apparently she got herself a new job. So we start at 1, which doesn't seem like a whole lot, does it? Okay, which a sub n equals a sub n minus 1, a sub 0 equals 1, a sub n equals 1. Our growth, we'd start at 1. Okay, then it's quadruples, so that's timesing by 4. So we're timesing by 4 each time. So 4, 16, 64, 256, 1024. So 4,000. So if she does it 6 times 4,096, not too shabby. So timesing by 4 to the n, timesing by 4, not to the n, timesing by 4. Okay, and then already it'd be growing pretty quick. Okay. All right. 2 more to go. A cable company charges a monthly fee of 5 cents for each on-demand movie watched. The cost triples. Okay, monthly fee of 0.05, and we're tripling, times them by 3. So 0.05, 1 would be 0.15, 2 would be 0.45, right? We're times them by 3. Then $1.35, $4.05, $12.15, and then $36.45. Okay, so graphing this one, 0.05, okay, 0.15, 0.45, 135, 405, then 12. So it goes up like that. For the equation, f of x equals f of x minus 1 times 3, and f of 0 equals 0.05. For our explicit, f of x equals 0.05 times 3, and because it's geometric, we make the multiplication. Okay, number 9, last one. Well, almost last one. Garrett borrowed $500 from his aunt. Okay, so we'll start with 500 up here. Okay, that's our starting point, 500. 500. Okay, she doesn't charge any interest, and he pays off 15% each month. Now, we're not subtracting 15% from 500. But if we think of 500 as equaling that 100%, every month we're subtracting 15% from the 100, giving us left over 85%. So our growth is actually multiplying by 85%, or 0.85. Okay, that's the easiest way for us to work this out. So if I go 500 times 0.85, we get 425 times 0.85, 361.25 times 0.85, and I'm going to round to the nearest hundredth, 307.06, because that's money, times 0.85, 261.00 times 0.85, 221.85, and one more time, 188.57. Okay, so if we start at 500, that would be 425, would be about a fourth up. Then that would be 361, would be a little above. That would be 200 and 100. So 307. Then 307, yeah. Then 261. Then 221. 188. That'd be more up there. So So this one's going to kind of curve really slowly. Okay, then our equation, a sub n equals a sub n minus 1, timesing by 0.85, a sub 0 equals 500, and then y equals 0.85, 500, times 0.85 to the x. Alright, so question 10, what is the importance of the starting number? Okay, y-intercept. Again, just like before, okay, that starting number shows us how things are working, okay, how they're starting. We don't really have the slope on this one because it's geometric, so we don't call it slope. You could call it its factor because we're dealing with multiplication. But again, it's showing that growth. It shows how things grow. Shows us how all of this is going to grow. Okay, so there we go, guys.